Welcome back to Educator.com. In this lesson we're going to continue on with our solving of equations by looking at some other solving techniques. Some of these techniques that we've seen before is of course using factoring to solve a quadratic equation. What we're going to add to that is the square root principle, how to complete the square, and everyone's favorite, the quadratic formula. Now, one of the first ways that you can solve a quadratic equation is really break it down into its linear factors. When you do so, you can use the principle of zero products. And we saw that the way that that really works is we treat each of the factors, say as a number, and we know that one or possibly both those factors must be equal to 0. So we borrowed each of them and set them equal to 0. Then we solved each one individually, and we got our solutions. Now, of course, one downside to using a process like this is that it really relies on our factoring techniques. So we have to be able to factor one of those quadratics and be able to grab them and set them equal to 0. Now, the reason why that is so much of a problem is because not all quadratics factor easily. In fact, some don't even factor at all if you're, really searching around. Let's take this one, like 2x squared minus 1 equals 3x. Suppose we wanted to solve that quadratic equation. Well, one of the first things we might do if we're trying to use that factoring technique is we'd go ahead and get everything over to one side. Okay, now that in itself isn't too bad. And then maybe we'd attack this using something like reverse FOIL. So we really only have one option to get 2x squared. We must use a 2x and an x. And there's really only one way to get a negative 1. We have to use a positive 1 and a negative 1. Now, the problem with this is if you go through and you check your outside and inside terms, here's what you get. A negative 2x and a positive 1x, which those combine and give you a negative x. That's not the same as our middle term. So we know that that factorization is not correct. Well, you might be saying to yourself, well, maybe we just made a small error. Maybe this needs to be a negative 1 and the other one needs to be a positive 1. Well, let's try that one out and see if it turns out any better. So on the outside, we have a 2x, inside negative 1x, those combine to be 1x, and unfortunately, still not the same as our middle term. Well, there is no other possibilities for rearranging our 2's and our 1's. Those are the only possibilities that I could use for my factoring process. Well, if I'm not able to factor this, then how are we supposed to be able to find solutions? After all, we still want to be able to find solutions for even quadratics like this. Well, it's for this reason alone that we really have to pick up some new methods for solving quadratics other than just the factoring process. So let's first look at a nice one and see the method we can use on that type of quadratic. In this type of quadratic, we only have one copy of x that is in the quadratic equation. So you don't have another x, just one copy of x squared. In these ones, the good news is you can solve directly. And this uses the principle of square roots. What that principle says is that if you have something like an x squared equals to a number, then you can really split this into two. You can split it into x equals the square root of that number, and x equals the negative square root of that number. And really what you're doing in practice is it's like you're taking the square root of both sides of your equation. The reason why you're getting one being positive and one being negative is the square here kind of erases information of what the sign used to be. So then we'll go ahead and give the plus and the minus sign to the other side. So x could have equaled 8, but maybe it was equal to a negative 8. So these ones are kind of nice if you can recognize that there's only a single copy of x running around and it's being squared. Now for more complicated polynomials, we'll have to use a very special technique. This one is known as completing the square. What completing the square does is it puts it into a new form, and we can simply apply the principle of square roots to that new form. The process of completing the square is a little bit lengthy, so let me walk you through how the completing the square works. The first thing that you want to do is really isolate your variables to one side, so get all your x's on one side. If it doesn't have a variable, go ahead and put it on the other side of the equation for now. Then you're going to want to make sure that the coefficient on your x squared term is 1. If it's anything other than 1, then go ahead and divide everything by that number. Then we'll be looking for a number that we can add to both sides of the equation so that it will go ahead and factor nicely. Now there's a great technique for finding this number. You take the coefficient on your x term, you divide it by 2, and you square it. After you've added that number, then you can simply factor. In fact, it should factor nicely at that point. I'm going to write should factor nicely. If it doesn't factor nicely, then double check your steps up to that one to make sure you followed them correctly. After we've gotten to that point, now we can use the principle of square roots. We'll take the square root of both sides and make sure that one of them is positive and one of them is negative. Then we will solve directly for our variable. So this is quite a lengthy process using complete the square, but if you methodically go through all of the steps, it does get the job done. Now the reason why I like completing the square so much is because it will work on any quadratic equation. We don't have to worry if it's a special form or if it's easily factorable. We can actually just use completing the square and it will work. Of course, there is one major downside to using completing the square. There are lots of necessary steps, and it makes it very easy to make a mistake when trying to follow it. The good news is all of these steps can be packaged up into a handy formula. That way you don't have quite as many steps to memorize. And this formula is known as the quadratic formula. So that's definitely something you want to know to be able to tackle many more difficult types of quadratics. What the quadratic formula says is that if you're looking at, say, a quadratic equation of the form ax squared plus bx plus c equals 0, then its solutions are given by this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now it's quite a lot to keep track of, but this is probably a good one to memorize. Now there is some good news. Even though it's not the prettiest looking formula, it's built directly from completing the square. And completing the square works on any quadratic, so you may also use this on any quadratic equation. It really makes it extremely powerful for solving a lot of those quadratic equations. Alright, so now that we have some more tools under our belt, let's take a look at using some of these new techniques. To determine what type of solutions that these many techniques will produce, we can use what is called the discriminant to help us out. The discriminant is actually just the part of the quadratic formula, but it's the part that sits underneath the square root. Now, the reason why that will really tell us what type of solutions we get is because depending on what type of number is underneath the square root, it could be real or it could be imaginary, it could be rational or irrational. Let's see how we can really break that down. If we're looking at the part underneath the square root, that's the discriminant, and say it is equal to 0. What that tells us is that we will get exactly one real number solution. If we're looking at the discriminant, and it happens to be greater than 0, so think some sort of positive number, then we know we will have two different real number solutions. Now this one's kind of special because you can take it a little bit farther. If that number is not only positive, but it's also a square number, your solutions will be rational. If it's not a square number, then it will be irrational. Then we just have one more case to worry about. What happens if the discriminant is negative? Well, in that case, you will have imaginary number solutions. So think of earlier when we were dealing with a negative sign underneath the square root. These happen to be complex conjugates of each other, but I'll explain more about these in another lesson. Alright, so with so many new techniques to solve a quadratic, how do you know what to use when just faced with any quadratic? After all, some work for only certain quadratics if they're factorable, and some techniques will work on any quadratic. Well, here's some good tips on when you should use these. The factoring technique that we picked up at the very beginning is one of the fastest methods you could use. This means if you're looking at a quadratic and you can see that it is factorable, then go ahead and use that method because you'll save yourself a lot of time. If you end up struggling with it for quite a bit, then maybe another technique is really what should be used. You can use the principle of square roots if you only have a single copy of an x squared. Again, this is kind of a nice method because it's a very straightforward method that doesn't involve, bringing in factoring, doesn't involve any formulas. You really just solve directly. If you're essentially stuck for too long and none of those methods worked out, then you could try completing the square. The good news is it should be able to find your solutions, even though it does have quite a bit of steps. In practice, we don't usually use that one since the quadratic formula is built from the completing the square, and it will also work for any quadratic equation. Of course, the reason why, again, we like the quadratic formula, it's a little bit easier to work with, and then we simply have to, plug everything into the formula and use it. Make sure you identify your A, B, and C terms, and know that this one is definitely faster than completing the square. Alright, let's try some of these techniques out, see how it does. We want to solve this first one using the square root principle. And to figure out why we would even use that principle, notice how there's only one x and it's being squared. So there really is no need to factor this one. We'll just go ahead and work on getting x all by itself. We'll add 5 to both sides. Then we will divide both sides by 2. And then we will take the square root of both sides. This is where that property comes into play, because I have x squared equals a number. So I'll either have x equals the square root of 5, or x equals the square root, and that is negative. Let's get some more space in there. Could equal the negative square root of 5. So again, just really solve for this one directly. Let's try the method of completing the square with this one. 2x squared plus 4x minus 2. There's lots of steps involved, so carefully watch how I walk through this one. The very first thing I want to do is really just start sorting things out. So I'll get everything associated with a variable on one side. And if it doesn't have a variable, I'll move it to the other side. So I'm adding 2 to both sides, so I don't have to worry about that 2 just yet. Now I want to check the leading coefficient to make sure that it's a 1. And unfortunately, it looks like this one's not a 1. So to make it a 1, I'm going to divide everything by 2. So 2x squared divided by 2 is an x squared. 4x divided by 2 is a 2x, and 2 divided by 2 is 1. Okay. Now comes the part where I need to add something to this quadratic so that it factors nicely. And the way we find out what this number is we look at the term in front of x. So I have a 2. We're going to take that coefficient, divide it by 2, and square it. And I often get a lot of questions like, should you always divide by 2 and square it? And the answer is yes, it's always divide by 2 and square it. So 2 divided by 2 is 1, and 1 squared is 1. So this number right over here is what I need to add to both sides of my equation. So there's all the original numbers, and there's that plus 1 on both sides just to keep things balanced. Now the reason why we're doing that is because on the left side it will now factor nicely. You could use the reverse FOIL method on that left side, and you would get x plus 1 and x plus 1. On the right side, we just get a 2. Now, if you do add the correct number to to both sides, these factors will always be the same. If they're not the same, then go back through and check your work, make sure you didn't make a mistake. But they will always end up being the same. So we're going to write this as x plus 1 squared. Now that really condenses things down, and actually at this point, this is where I can use my principle of square roots. We're going to use it because now I can take the square root of both sides to get rid of my square. So I'll have x plus 1 equals a positive square root of 2, and I'll have x plus 1 equals a negative square root of 2. And now I can solve each of these directly. So x equals a negative 1 plus a square root of 2, and x equals a negative 1 minus a square root of 2. So that one does take a lot more work, especially to go through the entire process of completing the square. But notice how it did find our solutions. And it even found our solutions despite the fact that they were irrational solutions. So very nice. Now, unfortunately, completing the square can be a clunky process, and that's really what I want to demonstrate with this next example. 2x squared minus 1 is equal to 3. Watch how, even though the numbers are a little bit more difficult to work with, I still go through all of the same steps in order to get my solution. Alright, so again, the very first thing I want to do is just get all of my x's to one side. If it doesn't have an x, I'll move it to the other. So I have 2x squared minus 3x. We'll add the 1 to the other side, 1. Now I need to check my x squared term to see if it's 1. And it looks like this one's a 2, so I need to divide everything by 2. That will give us an x squared minus 3 halves x equals 1 half. Notice how we now have a lot more fractions showing up. We haven't done the method wrong, it's just what the numbers turn out to be. Okay. Now that we've gotten to this point, I need to figure out what number I should add to both sides of my equation so that the left side will factor nicely. Remember, it really comes from this number right here. We'll take it, divide it by 2, and then take that result and square it. Well, just because it's a fraction doesn't mean we can't work with it. That's the same as multiplying by 1 half. So I get negative 3/4 squared, which is the same as 9/16. So 9/16 is the number that I should add to both sides. Okay, it's looking good, looking good. Now that we've gotten to this stage, the left side over here should factor nicely. Again, you could use the method of reverse FOIL to help you out. You know that your first terms will be x, and two things that would multiply to give you a 9 would be a 3, and two things that would multiply to give you 16 would be 4. Both of these must be negative since our middle term is negative. Okay, let's see what's going on the other side. I have a 1 half and I have a 9/16. Well, I can get those together by finding a common denominator. So 8/16 plus 9/16. Alright, so at this stage we have x minus 3/4. All of that is being squared. And then all of that is equal to 17/16. Okay, so completing the square does a lot of work for us. It really gets our x's together on the same side. Now we can solve directly using the principle of square roots and taking the square root of both sides. So x minus 3/4 I have the square root of 17/16, or it could be negative. I'm going to represent those by saying it could be the plus or minus of that square root. All right, I have one of my properties that says I can split up my square root over the top and bottom of a fraction. So the square root of 17 over the square root of 16, or x minus 3/4, equals plus minus the square root of 17 over 4. So we're getting really close to our actual solution. There's only one last thing I need to do. Let's go ahead and add 3/4 to both sides. So I'll have x is equal to 3/4 plus or minus the square root of 17 all over 4. Which, since these have the same denominator, I'll go ahead and just write them as one large fraction. Wow, that was quite a bit of work. But notice how, our answer was not a very nice answer. It happens to be another irrational number. And we have no hope of really finding irrational solutions like that using simply factoring. So completing the square is an important process for manipulating quadratics and still being able to find its solutions. I will admit, though, it is quite a lengthy process, so be careful that you follow all of the steps correctly. All right, of course, a much faster method than completing the square is our quadratic formula. The good news is it will also work on any type of quadratic. We just have to be careful to pick out the proper values and put them in their spot. To help out, I'm going to write down the quadratic formula up in the corner here. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a. That way we can reference it when we need to solve this one. So in order for this to work out, I need it set equal to 0 first. So let's get everything over to one side. I'm going to organize things from the largest power to the smallest power. Let's see, we'll have to subtract that 7 over, and now it's set equal to 0 just fine. Okay, so my a value would be 3, b value would be 2, and the c value would be negative 7. So we're going to take all of those and put them into the formula. So x is equal to negative the value of b, which I said was 2, plus or minus the square root, here's where we put in b again, 2 squared, minus 4 times the value of a times the value of c. So a and c. All over 2 times the value of a. So you can really see I've really just substituted the proper values into all of their spots. All right, now we have to go through and very carefully simplify this down. So we have negative 2 plus or minus 2 squared would be 4. Now I have a negative 4 times a 3 times a negative 7, so I have to really put all of those together. Let's see, what would that give me? I have 84 positive all over 6. So negative 2 plus or minus the square root of 88 all over 6. Now it's really important to go ahead and try and simplify this as much as possible. So when I have the square root of 88 in there, I can look at that as 4 times 22 and be able to take care of the square root of 4 and the square root of 2 separately. So the square root of 4 would be 2, and the square root of 22 has to stay. And then I can cancel out a 2 from the top and the bottom. So negative 1 plus or minus the square root of 22 all over 3. Again, notice how this answer was not so nice, but The quadratic formula really helped us find it. You just have to be very careful that you put it in the right spot and simplify carefully. One common mistake is watch your signs for the part underneath the square root. Alright, one last thing to do is to really use our discriminant to determine the types of solutions we'll get, no matter what method we use, by the way. And so the discriminant is just that part underneath the square root. So think of b squared minus 4 times ac. That is our discriminant. Now we can use this even though the numbers might get a little large. So here's my a, b, and c. So let's first just evaluate what this discriminant would be. So I'll have b squared, which is 70, minus 4 times a times c. Alright, if I look at 70 squared, 7 times 7 is 49. I have some zeros in there. And then 4 times 25 would be 100. 100 times 49, 49. And so what I'm getting for this first discriminant is that it's all equal to 0. Well, what does that mean in terms of my solutions? Well, if I was to look at the rest of the quadratic formula in there, it's telling me that this entire part is going to 0. So I'll either be adding 0 or subtracting 0. So I will have one real solution. Neat. Let's try out the next one. So I have a is 1, b is 4, and c is 2. Okay, so b would be 4, minus 4a and c, and now we'll multiply all that together. So 4 squared is 16, 4 times 2 is 8, and 16 minus 8 is 8. Alright, so this number is greater than 0, but it is not a square number. So what I can say is that I will have two real solutions. But since it is not a square number, they will be irrational. Not bad. All right, let's do one more. I'll identify A, B, and C. And we'll put that into our discriminant. So B squared minus 4 times A times C. All right, now it's time to crunch it all down. Negative 10 squared is 100. And then I have negative 4 times 3 times 15. So what is that? I got a 12 times 15. 2 times 1 is 2 plus 1. So I have 100 minus 180, or negative 80. So in this one, our discriminant is less than 0. That's an indication that we will have two imaginary solutions. All right. So by using the discriminant, you get a good idea of the solutions that you will get in your final answer. You can use a variety of techniques to go ahead and solve those quadratics and get your final answer. Know that factoring is usually the fastest, but the quadratic formula will work on any type of quadratic. Thank you for watching Educator.com.